Welcome back to my YouTube channel all about VLSI. In this particular video, we are going to discuss few interview questions and you can basically pause this video and think about the answer and you can come up with your answer and cross verify with my explanation, right? So this is a part 2 of interview question and answer series. Now, let's start without any particular delay. So the question over here is how does Verilog handle out of range vector indexing? What value is written and what are the simulation versus synthesis behavior? This is a question. So you can pause this video, you can think about the question and you can answer it. Yes, I hope you have answered the particular question. Now let's see what is the answer for this. So basically in Verilog simulation, accessing a bit index that is declared range of a vector, which is out of range, it is going to return x. So which is declared outside the declared range of a vector, return x for a single bit or x filled with part selects. For example, if I'm going to have a vector declared as reg 7 down to 0, v is equal to 8 tick h ff. So this is nothing but 8-bit 1111 so on 1111 like this 8-bit vector it is, right? Now, if I'm trying to access 8 index 8 which is not declared inside here, which is a out of range index. So the indexes are from 0 to 7 only, right? So if I'm going to access the extra index that is 8, it is going to return me an unknown value because it is not in the range, right? And if I'm trying to uh, have a path select of out of range like v of 10 down to 8 which is not at all there, right? So it is going to return me x x x x. So this is how it is going to work when you're trying to access out of range indexes, right? Yeah. Let's see next question. So explain how concatenation and replication operators works on a vector. Give a complex example combining both. So you can pause the video, think about this solution and you can resume for the answer. Yes, I hope you have answered this particular question. Let's see what is the answer. So basically, concatenation operator is going to join bits or vectors into a larger vector from left to right. Leftmost becomes MSB, right? So for example, if I'm going to write down concatenation of A comma B, where A is equal to 1010 and B is equal to 0110, then this A becomes MSB and this 1 becomes MSB and this B is nothing but my LSB, right? So replication operator duplicates expression n times. For example, if I'm going to write down replication operator 3 of A, so this A value will be replicated 3 times, like 1010, 1010, 1010. That like this, it is going to replicate it for 3 number of times. Both are zeros overhead in synthesis, just while routing. An important rule over here is concatenation operands must have known bit widths. Unsized constants are not allowed. And replication count must be a constant. It cannot be a variable. So they are commonly used for sign extension, bus packing, shift register initialization, and all. So for example, if I'm going to have a variable, reg 3 down to 0, A is equal to 4-bit variable, B is also 4-bit variable, and C is of 8-bit variable. Now I can concatenate these two and I can basically group it and I can have it, right? And one more variable, range 15 down to 0, D. What I'm going to do here, C is equal to concatenation of A comma B. So what is happening over here? C is the 8-bit value because I'm just concatenating this two. Now I can use a replication operator. D is equal to replication of 2 in 2 C. That means C will be replicated for 2 number of times. And C D value will be this 16-bit. And I can also sign extend A to 8 bits. How I'm going to extend? So basically, I'm going to write down 4 A of 3. So what is happening? A value is nothing but 1010, right? So what I'm going to write down is concatenation of 4 A of 3 comma A. That means A of 3 is nothing but my MSB, that is 1. So you can see, right, 1. So this one will be replicated for 4 number of times, 1, 2, 3, 4. And then A value will be given, that is 1010. So this is how a replication operator is used for sign extension also. Yes. So this is about this particular video. So, and we are going to discuss few more questions in our upcoming sessions. If you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.